All right. Hello, ladies and gentlemen. It is Monday the 19th. It's asynchronous. I'm taking a class on a reading for science class. I have to be done by the end of this week, so I took the day off. Happy Monday. Okay, I'm going to give you a video to watch. This is the video on a review of for the chapter test. So, a review of chapter test. And this chapter test is on weeks 13 through 16. Okay. Um, get your 5 hours in today, check the grades and work and bring those up weeks. Okay. So if we take a look at they're in the weeks 17, which we are on. All right. There's a graphic organizer that goes over the wave traits vocabulary, week 13. So sound and intensity, week 13. Prefixes, week 13. Week 14, wave interaction vocabulary. Wave 14, more interactions. And then week 15, electromagnetic spectrum, electromagnetic fields. And then Faraday's law. And then week 16, electricity and circuits. So there's like, see, 8 pages, 12 pages. So most of it is vocabulary. Okay, so let's go over the booklet I have hosted for today. I'm going to start this. All right, so I'm going to go over the 20 questions for the vocabulary. What is the definition of a wave? Let me see if I can answer this question. All right, so um, visible. Let me put this on pause a second. This vocabs. What's the definition of a wave? A disturbance that transmits energy without matter. Okay, so you get that from our definition as well. Next, get ready for the next one. What does an amplitude measure in the wave? It's the distance from the rest position to the trough, to the top. Okay, so it's the big bump in there. Next, which unit is to measure frequency, and that is hertz. Hertz is the measure of frequency. All right, I'm not competing against anybody. In the equation, velocity equals frequency times wavelength, that's F, and that lambda. The wavelength is what we're looking for when we're looking for the lambda. And again, like I said, it is in the notes. Which type of wave can travel through empty space? Sound waves need a medium like sound, water, or solids. Electromagnetic waves are the waves that produce and go through the vacuum of space. Waiting for the weekend. Well, we're waiting for summer break. Sound waves are classified as longitudinal or mechanical waves. Longitudinal or mechanical waves. Transverse waves are electromagnetic. Standing waves are also can also be electromagnetic. Did I get that one right? Through which medium does sound travel the fastest? So the particles that are closest together are the solids. Gases are furthest apart, so sound travels the slowest in gases and the highest in whoops, I ran out. Okay, solids. Oh, missed it. Solids. My computer, my phone went off and cut me out. All right, looking for the lost question. What happens to the wavelength when the frequency increases? All right, when the frequency increases, it decreases. It decreases, gets smaller. So when we're getting the frequency decreases, we get it, the wavelength gets smaller because the speed of light causes the wave to stay the same, right? The speed of the waves. So the only thing we can do is make them bunch together. All right, next question. What is the speed of light approximately equal to? All right, so I think 3 times 10 to the 8th is what I'm looking at, or 3 times 10 to the 9th. Let's try 3 times 10 to the 9th. Is that right? Nope, 3 times 10 to the 8th. Okay. All right, I was close. I did not get that one right. All right, got to look at my notes. What type of electromagnetic wave is the shortest? Okay, so the shortest is your gamma rays, where radio waves are your longest. Those are the highest frequency, which makes them really close together, a billionth of a meter. So it's like you're being hit by a wave a billion times in 1 second, and it causes a lot of energy damage, right? All right, ready for the next question. Which the relationship of frequency and wavelength? All right, so they are inversely proportional. So as the relationship, as the frequency gets higher, the wavelength gets smaller. As the frequency gets smaller, the wavelength gets larger. So it's an inverse relationship there. Did I get it right? Nope, I did not answer the question quick enough. All right. Next. What is the intensity of terms of sound? The intensity of sound is the frequency, the speed of sound. It's the power of the per unit time, right? Power per unit time, unit area, I should say. So frequency is terms of sound, and we list that in terms of watts, or we can list that in decibels as well. Right, number at what the decibel levels of sound cause you pain? About 120 decibels is where we cause the pain. That's like the jet you hear if you have no ear protection. So lots of jobs you have, if you're working in construction, for sure you should be wearing ear protection. Loading. Light waves are transverse waves. Transverse waves. Mechanical waves are sound waves. Light waves travel through space, so they are transverse waves. That's the up and down in comparison to the longitudinal, which kind of bunches things together. Next one. What is a photon? It's a discrete packet of energy. So light of a photon can hit metal and cause electricity to happen, creates electrical charges when it hits a metal, certain metals. The photoelectric effect demonstrates that light acts as both a wave and a particle. Both a wave and a particle. That's the dual nature of light. Can act as a particle, can act as a wave. Has interference patterns just like sound and water waves. How am I doing? Number 17. What are polarizing filters do? They make waves oscillate in the same plane, so they can make the light, so you can use your polarizing sunglasses and get reduced glare off the water where it reflects it and makes it shiny. So polarizing sunglasses are things to have to protect your eyes, but also to kind of see through glass that reflects light. Which prefix is commonly used for FM radios? All right, FM radios are usually called, let's see if I'm right on this. Oh, missed it up. It should be, where'd you go? Did I get it right? Nope. It's called, oh, yep, I was right, megahertz, but I did not press it in time. Megahertz. Number 19. What happens when you increase the intensity of light and the photo effects, photoelectric effects? More electrons are ejected. More electrons are ejected. So that's how like a solar panel works. Oops, got to press it quickly. So the more energy, more electrons are ejected, and then you get that effect where the solar panel works. Last question. Visible light waves are typically measured in nanometers. Nanometers, 500 to 740 nanometers. Oh, I'm sorry. Visible light waves are measured in meters. I think I got that one right. Should be nanometers in that particular case. So again, like I said, take a look at the energy here. So here is what we just talked about, the wavelengths here in week 13, the amplitude, the trough, the wavelength, mechanical waves versus longitudinal waves, vibration in the same direction, transverse waves perpendicular, so that, and then the speed of sound is in here. See if I make the okay, so 120 decibels, it shows here the jet. So you can hurt yourself. The intensity of sound, see the speed of light. So 1, 2, 3, 6, 7, 8, 8, 3 to the 8th. Visible light, prefixes. Polarizing light, photoelectric effect, dual nature of light. Okay, I think we've got all of that, all the particular notes there. Now, you have some fun FET assignments that you can do, not assignments, but simulations. So you got John Travoltage. You can, this is how you get electrical charge by shuffling your feet. Okay, so you can also put your finger down closer. So if you bring your finger down closer, it'll shock you quicker. But there, you're building up electrical charge on yourself, and it has to be released. Another one that you have to play with is the Ohm's law. So if we keep the voltage the same, and let's get our resistance here, is if we lower the resistance. So if we lower this resistance, so we're at right here, it's about 500. If we go 250 approximately, you'll notice that if we reduce the resistance and keep the voltage the same, we'll get an increase in the current. We'll get double the current. So let's see what happened here. So here we have voltage at 500, right? About 500. Yep, 500. Let's do it. Close. 9.5 milliamps of current. If we bring it down to, if we reduce it to half, we double the current. 19, went from 9 to 19. So this is what we call an inverse relationship. Increase the resistance, reduces the current, decreasing the resistance, that is the slowing the electrons through the material, we increase the current amount of power that's flowing through, right? Also have Faraday's law here, Faraday's law. All right, I have, you can experiment with this. Here is moving a magnet through a coil of wire. By moving it, this is an induction. We get electrical current and we can light up light bulbs. That's how generators work. A moving magnetic field through a wire. Now, again, if you notice here, if I have less coils, notice I don't have near as much light or electricity compared to. So we're influencing the electrical charge in the coil of wire. We're not touching it, but the magnetic field is passing through. So these are some things that you can play around with today. All right, so if we look at our assignments this week, let's go back over here. Week 17, graphic organizer. Here's the John Travolta simulator. Week 17, assignment 1, part 2, it's review. There are 15 points of review vocabulary. Ohm's law, a simulation on, so you can do that today if you'd like on the 19th, or play around with, but use the graphic organizer to help you answer those questions. Take some notes, put it in your offline tracker. Ohm's law simulation tomorrow or Wednesday, part 2 for the vocabulary review or the test review. Remember, you have 13 through 16, so there's 13, 14, 15, 16, 4 chapters that 4 weeks that we're working on. Faraday's law, and then Friday, 60-point test. So this is the last one. It's due on the 23rd. Okay, so that's what I have for you today. I will be back tomorrow, Tuesday. Have a great day, guys.